All right, cool. So we're going to do Q&A now. Any questions that we have, I'm happy to kind of kick things off. But if you have a question, just go ahead and raise. If you don't want to come up to the microphone, I'll repeat it. Otherwise, just go ahead and go up to the microphone. Yeah, go ahead.
So on the cross, there is one phase which is to make the configuration or the network view web diagnostic. That's one thing. But my question is, based on your experience, is there anything which the devices or the systems can provide which will make the intent-based networking deployment easier or maybe more effective? Provide extra that is not there today?
Great. Let me just repeat the question for everybody else. So the question is everybody is assuming existing gear and then dealing with the complexity of that. Is there any way the switches can evolve with basically a southbound interface that would help this? I think I'll just kind of open it up. I think everybody has something to say about that. Dave, do you want to pass the microphone to? Or you lapped up? Okay, you didn't need it. Okay, got it. Sorry.
I can just use that.
Right,
okay. Well, so I must admit it's similar to my comments about assembly language. That if they provide APIs and they provide them faster, they're more complete and they're faster. That's the biggest assistance right there. I think. It's kind of like asking, what can Intel add to the instruction set to make Java run faster? Well, maybe a few things, but a faster machine is the best thing.
Give you a slightly different answer maybe. You can ask all of them to be bug compatible and we'll be done.
I was trying to be realistic.
So I agree completely with that. One thing I would add is that as the industry moves, hopefully successfully, towards that more API-based world, another benefit that you can get is not just making it easier, but making it more efficient. So you can drive down, the technology exists so that you can do verification at millisecond level, response time. But right now, just extracting the data from devices can take much longer than that. So in addition to making it easier, there's this efficiency benefit to be had as well.
To add to that, we've come across devices where the only way to build a complete picture of that device, right, to build a complete forwarding model, is to use SSH to get information off. And that's never going to be a fast or efficient way. So I think also OpenConfig is looking at standardizing some of the configuration in the data plane side that would help us get the data off faster and in a more standard way.
Greg's comment is it assumes the devices are reliable enough to be configured properly, which I totally agree. Hey, Rob.
Rob Sherwood, apparently the really loud mic. I think everybody up there knows me and knows that I mean this with a good intent. It's not clear to me, and I'm playing devil's advocate a little bit here, it's not clear to me what's different about intent-based networking, right? Like I got into a discussion with Radia Perlman 10 years ago now about, she's like, I don't understand why networking needs knobs. You just enable spanning tree, right? And we've had spanning tree for a long time. You turn it on, it either works or it doesn't. And all the intent is behind that. What's different about this larger class?
Well, it sounds like a free-for-all, man. Maybe we'll start at Brandon and head back this way.
Yeah, so I think the pieces here have been brewing for a really long time, and there are elements of SDN here. There are kind of elements of a variety of pieces of stuff that's happened in the research world. I think what's nice about intent-based networking is that it seems to be this umbrella that unites all the stuff that people have done. So it is a buzzword, but I think it is actually a useful one.
So I was going to say, I think I agree with it being a buzzword. So I can just give you the way I look at it, which is basically any technique that reduces the gap between intent and reality, to me, would fall under that umbrella. I don't quite know if there's one technology that you'd call intent-based networking. I don't think there should be. I don't think there is. So I think what has changed, and Brandon's answer is alluding to that we in the research world and based on the operations coming world from automation and SDN, a certain set of techniques now have been enabled to let us bridge that gap. And I think that excitement gets captured in this keyword, so to speak.
So, I think there's a broad goal that unifies SDN and IBN, which is we're trying to make the network more programmable and achieve those high-level goals. In kind of the kind of common conception of what SDN is, that involves this open interface to the data plane, it involves a centralized controller, and then you can build those abstractions on top of it. And I think intent-based networking is really just emphasizing that top piece, and it could be that what you use below is, you know, existing traditional gear, you know, running BGP, right? So that's, I think, one point. It's about the results, not necessarily the interfaces to the data plane. And second, I'd say that there's this been kind of unifying, you heard it in a lot of the talks, this whole control loop, the closed loop, kind of bringing sort of the DevOps mindset to planning and building and operating the network, with not only, you know, provisioning the network automatically, but also verifying it and closing the loop there. So I think those are kind of two new threads in the IBN conversation.
Yeah.
So I think I understand intent-based as new based, you know, similar to this analogy to a self-driving car, that, you know, that when you look at the end user operator, when somebody gets in a car, you say, what's your intent? And it's not to back out of the driveway, it's not to turn left, turn right. They're trying to get to grandma's house, and that's their intent. And the ability to say to the network, my intent is this. Go figure out how to do it. We do the same thing with a self-driving car, and we call it a self-driving car not because it figures out that we need to go to grandma's house. It needs some level of what do you intend to do in this car, but it figures out the rest of it. And I think that's where we've up-leveled to a point where we're taking out a lot of the complexity. And I think the key thing with the self-driving car is at what point is it less mental load? At what point does it require less skill, less time, less involvement in the human being? It's when it really operates itself, but it has to know what you want it to do that. And that's where intent comes in.
Okay, that's good.
Rodrigo Fonseca from Brown University. So a couple of the talks, Ratu and Brighten specifically mentioned that monitoring is too little, too late. So in this new world of intent-based networking, it's unlikely that monitoring will go away because eventually there's an assumption that you make implicitly that, oh, when you tell a device to do something, it will do that something. So it's not going away, but also there seems to be an opportunity to make monitoring more intelligent, right, by learning from the intent. So how do you see, how does monitoring look like, and how is it better in this new world in which you actually know the intent of the operator? Yeah.
Go ahead.
I'll take it. I think you're absolutely right. I don't think any of us here is arguing that monitoring should go away. I think it should and will stay an essential part of the pipeline. I think what has changed that if engineers have done the hard work or the harder work of specifying intent, monitoring can be all of a sudden be more meaningful by essentially closing the loop. And I think this is what like some of us are saying, that like what you check for changes, you have more context. One of the biggest problems with monitoring, in my view, has always been that like it's too low level and lacks context. So when I say it lacks context, it's actually don't know what it's looking for, typically, and then it becomes like a backward exercise. Is this right? Is this not right? And we end up building essentially, you know, a pile of cards. I think what changes now is that like monitoring itself can be more, I don't know, for lack of a better word, intentful. And so it knows if you have high-level specification coming from verification or coming from synthesis, you know what should happen, and then you basically can then during monitoring focus on things that look out of whack, and that reduces a huge cognitive overhead for the engineers to see actually just focus on what's wrong.
Brighten, do you want to?
Yeah, I think, you know, we've talked about this, the many layers that go into a network, and really you want to know everything, right? You want to know the intent, the specification, the configs, the data plane, and the running state of the network. And then you can do very interesting things when you put all of those pieces together. You know, so I think we were emphasizing verification as what's you know, more distinct from what people are doing today. But you can put those together and do, you know, cross-layer consistency checking, for example. And you can think of many other interesting kinds of analysis that unify those different data sources. So yeah, I think they become more than the sum of their parts when you put them together.
I think the other thing I'd add is, I certainly agree that monitoring isn't going to go away. It's absolutely necessary for closed-loop verification, but I think that monitoring is not a single layer. You have monitoring within hardware devices that things are working correctly. You have monitoring within the switch operating system. You have monitoring at higher levels. I think what changes is that when you have this high-level intent, you're able to collect that monitoring and decide what level it has to percolate up to pay attention. Now, this is again my tired old analogy with a self-driving car. We don't get to a self-driving car by creating a dashboard with 1,000 dials on it. In fact, we reduce the number of dials because the car can know what you intend to do, and it only has to inform you about things where it can't obey your intent. And I think in this multi-level of monitoring, we can collect more monitoring, but we can process it more intelligently because we know what's relevant to achieving your intent.
And to add to that, in a sense, intent makes monitoring more testable. And so monitoring has this problem of, if we're above a threshold, then is our network still running, right? Is our network operating as it should? We don't know, right? We can have false positives and we can have false negatives where the loads may be kind of low, but we still aren't getting the behavior we actually want. And so kind of adding to your point there, you've got a way to take the intent now and kind of merge it in with the monitoring that you're doing to make both smarter.
Cool, thanks. Go ahead.
So I'm Brian Wong from Capital One, and perhaps I've stumbled into the wrong thing because I'm not a networking guy.
That's the right place.
That'll become apparent from my question, which is why would you limit this to networking? I mean, it seems to me that I have exactly the same problem of specifying and validating intent for all of my computational infrastructure, whether it's computation or libraries or middleware or storage or anything like that.
You guys can solve the distributed leader election problem.
Well, let me say one thing from an abstract standpoint. We think what we're doing is more broadly applicable than just data center networks, which is our initial focus. And it always pains me, coming from an academic background, I'd like to solve the general problem, but the reality is the devil is in the details in the real world, and so we've just focused on data center networks because what matters is getting one thing really, really right, and that's where we think it's the most valuable contribution.
Clearly, wouldn't want to walk correctly before you fly, right? But it seems to me that all the things that I need are just other examples of things that I need to collect data about and to model and then to verify or validate. I mean, same thing, right?
I agree completely. I think, and in the research world, there is pushing on verification specifically to kind of broaden the models into richer and richer models of, the elements in the whole system. Where we are in verification is there's kind of a continuum, right? There's on the one hand, there's systems that are very simple that you don't need, you can just stare at it, it's 2 lines of code and you know what it does. Hello world, right? At the other end of the spectrum, there's like totally arbitrary software that verification is infeasible for general purpose software in general, right? You can't guarantee that you'll be able to prove properties about it. Network verification is kind of in that sweet spot in the middle where it's way more complex for humans to be able to handle, but it's within the scope of what machines can analyze. So that would be the challenge, that as you go broader and broader, can you effectively and scalably analyze, as well as handle all of the other problems like building a unified model and so on. But that challenge is there, but it's definitely something that the more you broaden the scope of what you're representing in this whole big distributed system, the more value there is.
Go ahead. Any question?
I'd like to go back to one of the first questions and really challenge the panel. Just the whole idea of intent, you seem to be floating above the network. I mean, SDN changed how we thought about networks by forcing the re-architecture of the basic switch. If intent-based networking does not change how we do routers and switches, is really always going to be floating on top, and essentially playing catch-up. It's not really changing things. It's just a better API into the router switch. Doesn't seem to me to help things. I can see how it helps, but it doesn't change.
Yeah.
Just
maybe Brandon,
challenge.
take a crack and we'll work back this way.
Yeah, so I think it's a meaningful change if the ultimate reliability of that system is changed, if you've eliminated the possibility for many errors, or if you can detect them very quickly. So whether the underlying mechanism looks somewhat like a traditional network with message passing in a fully distributed, eventually consistent approach, whether we move toward a more SDN approach where there's more centralization of control, I don't think that's actually, I don't think we're intent-based networking is really forcing any particular direction. In a sense, it's saying what we should be doing is defining the goal, and whatever means are necessary to achieve that, whatever means have the best scaling properties, have the best correctness properties, whichever ones we can implement, those are the ones we should use. Anyone else want to add?
I was going to add to that. I think from the following, maybe the analogy I think will help, and I think David touched on that in talk. I think if you look at programming languages, right, I think we've gone to higher level intent specification with those languages, and development of those languages has not required that we change the underlying x86 architecture. So, but still progress has been made in terms of how fast software gets written and how correct software gets written, is because the interface that the human sees for a lot of humans out there, engineers out there, has changed, and it's now high level, it's much cleaner, much simpler. So the guts don't necessarily need to change to get a lot of the value out of there. The other thing I'd add to that, I think the key value in actually raising that level of, raising that interface at which engineers operate, it actually frees the system later on to actually change the guts. Today now, I think changing the guts and that interface together and moving both things together, it's a much harder problem than I think where networking can go. Let's raise the interfaces now based on verification, synthesis, whatnot. And tomorrow, then we are free to change the guts.
Let's just, so this is the last question. We've got about a minute and a half left. So go ahead and ask a question. We'll go through that.
Quick one, is there a common intent language that everybody is kind of coming around to, or is everybody coming up with their own if-then-else statements that we have to learn?
Dave, do you want to start?
Well, first of all, if-then-else is imperative programming, so it's not intent.
You know what I mean.
Just to be mean. I think that there is sort of a common language. I'm tempted to call it network operator English, which everybody understands in the networking world. What we've done is provide APIs where you can specify things, and I think it's just a little premature to actually try to standardize this because it's early times here. But I think that I don't see that there's any critical differences. A lot of the, again, I draw out this programming language analogy that the hardest problem was decoupling ourselves from assembly language and getting up to a higher level. Once you're at Pascal, moving to C or vice versa wasn't so hard. Once you're at SQL level and so on, using different databases is not a big problem. So I think we'll see some standardization, and Apstra would certainly welcome that and follow that.
Okay. So we've just run out of time. Thanks everybody, and please thank the panelists for the great talks.